All right, boys and girls, let's take a look at the first of our half-life problems. And I posted this sheet to Google Classroom. Problem number 1 begins an isotope of cesium-137. Right, that's one we're looking at. So I have cesium-137, that's CS for cesium. We're not told in this problem what kind of decay it undergoes, but let's assume it's an alpha decay. It really doesn't make a difference for half-life problems. But let's say I get an alpha particle, which is 2 protons and 2 neutrons for a total mass of 4. And as a result of that decay, I end up with some new daughter nucleus. In order to figure this out, we need to know how many protons cesium has. And if you get your periodic table out, take a look down here. Cesium CS has 55 protons. So if I remove an alpha particle from this nucleus, the remaining nucleus will be 53 protons. And 53, again, if you look at it carefully, at your periodic table, 53 is iodine, right? Iodine. Now, what will the mass number of iodine be? Well, an alpha particle removes 4 particles, 2 protons, 2 neutrons for 4 mass units. So my 137 gets reduced by that 4, so it'd be 133. Take a note real quick here that if I add the numbers, the bottom numbers on the right-hand side of the equation, 53 and 2, I better get the 55 that I started with. Same thing with the mass numbers. 133 and 4 make 137. Now, as this decay occurs, the amount of cesium atoms goes down, whereas the amount of iodine atoms would be going up. Now, the rate at which this process occurs, we call that rate the half-life. The half-life is the time it takes for 1/2 of the radioactive sample to decay. And if you read through the problem, we are told here that the half-life is equal to 30 years. In this case, the half-life, T1/2, is equal to 30 years. Right? T1/2 is the symbol that we use for half-life. T for time, right? So that's the time element, and the 1/2 just means half-life, half-time. Second sentence, if 1 milligram of cesium disintegrates over a period of 90 years, how many milligrams of cesium-137 would remain? Let's think about this. Let's say I had my cesium-137 formed into a block, cesium-137, and I weighed this and I know it's 1 milligram. Over time, as the cesium atoms decay into iodines, the amount of cesium goes down. And according to our half-life, in 30 years, I know that it would have been reduced by 1/2. So instead of 1 milligram, I would now have a cesium-137 sample that's half as big. It's only 0.5 milligrams. 0.5 is half of 1. Right? As we continue to go through time, go through another half-life, through another 30-year period, the amount that I began this period with, 0.5 milligrams, gets cut in half again. Right? So my cesium-137 is not 0.5, but half of that, 0.25 milligrams. Now I'm going to go and progress through another half-life, another 30 years, and the 0.25 milligram sample gets cut in half again. So now it's 0.125 milligrams. it gets progressively smaller. The number of cesium atoms that are present is cut in half every 30 years. Now, I went through 3 half-lives because that would give me a total of 90 years, which is what the problem specifies. All right. Total of 90 years. It's 3 half-lives. I get cut in half 3 times. 1 milligram to 0.5, 0.5 to 0.25, 0.25 to 0.125. So the answer to problem number 1 is right here. The amount of cesium-137 left over after 90 years is 0.125 milligrams.